Hello students, today we are going to discuss about the types of languages in Turing machine. Okay, we normally have three types of languages here, and the outcome of this topic is you will be able to find out if a language is given to you, you can estimate whether that language can be accepted by Turing machine or not. If it is not accepted, then in which category the language can be placed. You can identify the type of language. Okay, so this is about the outcome of the topic. Now coming to the topic, we have three types of languages in Turing machine. One is recursive enumerable language, which is also called as RE. Next one is recursive language, abbreviated as REC, and the third one is diagonalization language, which is abbreviated as LD. Okay, we will see one by one. So coming to the recursive enumerable languages, the languages which are accepted by Turing machine, that is if a string is given, then the last symbol of that string will reach the final state after processing from initial state. Okay, it reaches the final state and it halts. Then such type of languages are called as recursive enumerable languages. This term is used especially for Turing machine. This is also called as type 0 language or type 0 grammar. Okay, and the languages that are accepted by finite automata are called as regular languages. The languages that are accepted by push-down automata are called as context-free languages. And context-sensitive languages are the languages which are accepted by linear bound automata. Okay, then in case if the string does not enter the final state, that is you have been using a string which is not belonging to a language which is acceptable by Turing machine, then that string will stop at some intermediate state of the Turing machine, and it will be stuck up there, and it will sometimes it enter into a loop, and the machine will go on executing that loop again and again, and the machine will not halt at all. It may halt or it may not halt, we cannot guarantee that. Okay, so this is about the recursive enumerable languages. And coming to the recursive languages, these languages will make the Turing machine to halt at a state, whether the language is acceptable or not acceptable. It won't make the Turing machine to run in a loop, and it won't create any disturbance in the working of the Turing machine. Okay, in case if the language is acceptable, it reaches to the final state and it will stop. That final state we may call it as some state Q, and it will stop at the final state or at the halting state. In case if the language is not acceptable, then it automatically stops in between the transition and it will reach the halt state. So this is about the recursive language. And the third one is diagonalization language. These are the languages that are not accepted by Turing machine. The strings or the languages which you cannot process in the Turing machine, all those are categorized as diagonalization languages, which are abbreviated as LD. Now this diagram shows the relation between these three languages. We have RE, that is recursive enumerable languages which are acceptable by the Turing machine and they will reach the final state, and recursive languages are, they may be acceptable or they may not be acceptable, and they will definitely stop in case if they are not acceptable by the Turing machine. So recursive languages are a subset of recursive enumerable languages, and these two put together comes into a language called universal language, which we write as L suffix U. Okay, so the universal language contains the strings which are acceptable by Turing machine, and the strings which are not acceptable, but you can stop the Turing machine if they are not acceptable. And the languages which are not at all acceptable by the Turing machine, they come under the diagonalization language. Okay, so they are not passed to the Turing machine at all. So this is about the types of the languages in Turing machine. Thank you.